What's up, Spice Heads? Thanks for joining us for today's webinar, Hyper-Converged, the New Normal, brought to you by Probrand. Before we get started, I'm going to go through some quick housekeeping items. Firstly, this webinar is being recorded, so keep a lookout for an email from us with the link to check out the webinar on demand. Secondly, there's a Q&A box on your screen. When you submit a question, it will disappear from your box and queue up on our side. So don't worry, we have it, and we'll ask those questions at the end. If we can't get to your question, we'll be able to follow up with you after the event. Lastly, we do have a live chat during the duration of the webinar, so jump in and chat with your fellow IT pros. Now let's get the show started. Today's presenters are Mark Lomas from Probrand and Mike Rhodes from Dell EMC. Mark, whenever you're ready, take it away.
Hi everybody, Mark Lomas here from Probrand. We're a specialist provider of IT services, solutions and products based in Birmingham, UK. I'm just going to get things started with a brief sort of introduction to Hyper-Converged before handing over to Mike. I'm going to sort of talk a little bit at a sort of very high level of Hyper-Converged before we get into the specifics later on. But before we sort of get started into that, I think it's a good idea to sort of start off with a fairly basic review of where we've been and how we've got to where we are. So a little bit of a sort of history, which for some people I'm sure will be fairly straightforward stuff, much of which you'll probably be already familiar with when we look at IT stacks and how we've defined that in the past prior even to virtualization coming along. So breaking it down into compute, storage, networking, management, those kind of layers. There can be others and there can be various ways of combining these together, but this is a fairly simplistic view just for the purposes of setting the context. So when we talk about compute from a historical perspective, we of course were talking about physical servers, rack servers, tower servers, blade from the perspective of helping us consolidate physically. Storage, which would have been direct attached storage, DAS, and of course SAN. Networking, of course, switching and cabling, and management software to try and help us make sense of all of this, manage it, keep control of it, that kind of thing. Now, thanks to the progression of technology generally, whether it's software or hardware, we've of course been able to move on. So if we introduce virtualization at the compute layer, which is of course a good area where a lot of people will understand that, we've had virtualization to reduce the physical footprint of our IT, particularly in the arena of servers. We've got greater and greater server resource available to us, so we can do a lot more with it. We can use virtualization to deliver more workloads on less kit and reduce down the physical footprint of our IT through the use of virtualization. And of course that allows us to start to think of our servers and our compute in terms of it being a discrete pool of resource rather than just separate siloed physical servers. We start to think of this as a resource pool that we can throw our workloads into. And of course that has a knock-on effect on the other areas in our stack. It has a knock-on effect on storage. Of course, SAN's become quite important in order to unlock some of the more advanced features of virtualization, like migration, failover, that kind of stuff. Of course, the impact on networking and our cabling becomes quite pronounced in that things start to change a lot. We've got more traffic going in and out of each individual host server. And of course, the management software has to adapt to take into account that it's looking after a virtualized world. But of course, we're not just thinking about virtualization these days as being purely about compute and about servers. Now we can virtualize storage, we can virtualize networking, and management just becomes part of the equation. But whereas it's possible to build these as individual components and build your pool of compute resource through compute virtualization, do a similar thing with storage, a similar thing with networking, we want to, of course, get to a position where we can say, okay, well, once we've got these into discrete pools of resources, can we combine these together to deliver all of this as a package? Now, before we move on and start to analyze that in more detail, it's perhaps worthwhile taking a step back and looking at some of the other ways in which we can think of IT as a resource, think of it as a pool that we can just consume. And of course, this is the stage where we start to look at things like cloud. Now, of course, when we look at historically from an on-premise perspective, you can have quite a high capex associated with your own on-premise IT. You've got to buy all of this kit, of course. Now, that can lead to a scenario where IT can be rather inflexible. You've got to think about procurement in the arena of on-premise IT. So when we talk about this as being inflexible, we're not necessarily talking about the actual software and the hardware. Of course, we've gained a high degree of flexibility thanks to virtualization, but we've still got to go through the various cycles of designing it, procuring it, implementing it, potentially as separate aspects. And of course, we've got the management overheads that go along with that. Moving over to public cloud, a lot of people will look at this and say, well, this gives us the ability to have an extreme level of agility with our IT. It's just a pool of resources, again, that it's not even our resource, it's a public cloud. We can throw workloads onto that at will. But it potentially leads to significantly unpredictable OpEx in our cost profile. And the reason for that really is that there's a potential reduction in IT efficiency. Now, why would you care about that when it's not your own IT, it's not your own hardware on a public cloud, you're just throwing your resources onto it? Well, because it still costs money. Even though you've switched that to an OpEx spend, you've still got to think about the cost profile of that. And if that cost profile is going to be unpredictable, where you're not necessarily sure what your costs might be from your public cloud provider from one month to the next, you do still need to concern yourself with efficiency. But that often doesn't get the attention that it deserves. If you think about it, if you're a Microsoft or if you're an Amazon and you're providing a public cloud resource out there, you're not really going to be too bothered if somebody over-provisions the resources that they're then paying for, because you're able to then get your money from that without necessarily having to provide the maximum resource that's been requested. So that level of efficiency still needs to be focused on, but it doesn't always get that level of attention. So because of the cost profile that then throws up, people start to increasingly look towards a hybrid cloud approach. But of course, there are certain advantages from cloud that we want. We want that extreme level of flexibility. We want cloud-like flexibility, but from an on-premise infrastructure. Now, to sort of analyze that in a slightly different way, we can start to think about the, I guess, three different ways that we can acquire the IT resources that we need. And that is to either build, rent, or buy. You can obviously build your own IT stacks, the traditional approach. Now that gives you a huge amount of flexibility from an IT perspective, but business managers might not necessarily be so happy with the CapEx spends and the costs associated with that, or indeed the design timescales that are involved in sizing and planning and implementing these solutions. So sometimes there's the push towards renting, moving towards the IT cloud approach of something as a service, software as a service, platform as a service, infrastructure as a service, all of these terms that we're now familiar with. But as mentioned on the previous slide and here, there can be an unpredictable cost model associated with that, where you're not necessarily sure what you're going to be spending from one month to the next. Plus, there can be potentially quite a high level of control that you're losing in that environment, and it can lead to a lack of efficiency that actually increases costs over time. So being able to buy your IT as discrete chunks of resources that you can still manage on-premise, still be looking after as a solution, but significantly speed up the cycle of procuring the IT resources and components that you need, leads us to this modern hyper-converged approach where we can do exactly that, where we can acquire chunks of IT resources to simply throw in as necessary. Now, if we go back to this slide where we were looking at the discrete pools of resources that we might have as part of a software virtualization stack, what we actually might be talking about with Hyper-Converged is more of an appliance that gives us all of these resources in one procurement package, that we can get hold of all of the compute, the storage, the networking, and the management software in one blow, in one purchase of the resources that we need. And of course, scale it over time so that if we need to throw in an additional appliance, we can do so. And then simply group together all of the expanded pools of compute, storage, and network resources with that management thrown in across the expanded pool. And of course, just keep scaling over time as needs be. Now, to summarize what that ultimately means is that you end up in a scenario where you can start to break down the previous approaches that you might have been taking to acquiring your IT resources. So you can stop building IT stacks and avoid the time required to individually size and design the right servers, start deploying IT infrastructure as a pool of flexible resources, and then embrace a pay-as-you-grow model. Now, just those first 3 points, taking them together, embracing a pay-as-you-grow model can be superficially very similar to the sort of cloud model as pay-as-you-go, but there are subtle differences. So when we look at the cloud model, it's very much a sort of tariff-driven pay-as-you-go approach, and it leads to that unpredictability around some of the cost models involved, whereas the pay-as-you-grow approach in Hyperconverged is really emerging from the fact that with a pay-as-you-grow approach on Hyperconverged, you can acquire as much or as little IT resource as you need at the outset. As an organization, you might decide to size a Hyperconverged deployment purely for the needs that you have today, and then in 12 months' time, maybe expand as your needs grow. Or you can start off by buying a larger chunk of IT resource to last you for a longer period of time. You do have that choice and that flexibility to scale these things exactly as you need at the outset and then expand later on, and then giving you that pay-as-you-grow approach, giving you that hybrid position between a CapEx and an OpEx spend. It's a little bit more predictable. It allows you to push costs into more of an annual budget model, for example. So then you can start to deliver a higher level of agility and adaptability with virtualization benefits across all aspects of your infrastructure and keep open the hybrid cloud options. Many systems now with Hyperconverged will integrate fully with the cloud and again allow you to move your workloads back and forth between cloud and on-premise environments. Again, you're just using these pools of IT resource. Everything becomes a pool of resource that you can start to consume, whether it be on-premise or in the cloud. But because you've got that hyper-converged approach in place, it gives you that freedom and flexibility to be able to consume things as pools of resources rather than silos of individual IT infrastructure. Now that brings us to the end of my section. So at this point, I'm going to hand over to Mike Rhodes from Dell EMC. Mike.
Thanks, Mark. So yeah, just really building on the message that Mark's come from and just focusing really on the infrastructure element of an IT system. And by that I mean, server storage, networking, the operating system, the hypervisors, the applications, and really focusing on the business value that those applications can bring. And what we're finding more and more is IT organizations that are really stretching the boundaries of their capabilities are asking the question about why they have to worry about keeping the proverbial lights on their infrastructure when they'd rather spend time innovating and driving real value back into the business. And I'm a big fan of a picture painting 1,000 words, and the analogy we like to use here is one of a car. There are relatively few organizations or very few people out there who go out and build their own cars. At one end of the spectrum, you've got the guy, the hobbyist, who builds a kit car. He spends every waking hour, all day Sunday, in his shed or in his garage, building his car, lovingly crafting it, tweaking it. And when he's finished, invariably will sell it and go and buy a new kit car. At the other end of the spectrum, you've got the likes of Formula One teams who will absolutely need that ultimate performance at a very specific use case, and they will invest tens, if not hundreds of millions of dollars to actually get that perfect solution. Everybody else typically goes down to a dealer to buy their vehicle. They drive their vehicle, they fuel it regularly, and if there's something that goes wrong with it, they don't try and fix it themselves. There's a warranty to provide that support. They'll take their car back to the dealer and say, there's a light on my dashboard, there's a problem with the brakes, please go away and fix it. Now, they may well know that the brakes are manufactured by Bosch, but they won't pick up the phone to Bosch to tell them there's a problem with the brakes. They'll go back to the place where they bought it from and make it the problem of that dealer, that manufacturer, to actually go and solve the problem. And that's the analogy that we've used time and time again in the world of IT infrastructure. Yes, there are people who have very specifically performance use cases who will go out and build their own infrastructure, pick the best of breed elements and components, integrate them together, and provide that ongoing support themselves for that integrated system. The vast majority of people in the market these days are looking for a platform on which they can build their applications, because ultimately it's applications that drive business value and really turn IT from what has historically been a cost center into something that really can help innovate and help the bottom line of an organization. So, that whole build it yourself versus buy it, and we're seeing more and more organizations moving into that buy phase of their maturity with IT rather than continuing down that build route. It's worth talking really. So I work for a company called Dell HCI. Our organization has recently joined together with the coming of Dell and EMC. And part of that merger was the integration of a company called VCE. Now, VCE, Virtual Computing Environment, what those letters stand for, but fundamentally, that organization pioneered the way around converged infrastructure. And by that, I mean they took traditional server platforms, storage platforms, and networking platforms and integrated them. And we had a very, very clear ethos around our differentiator in the market space. And that was really around those 5 pillars that you see on the slide. So we start on the left-hand side, and we've thought about engineering. So by that, I mean we have a team of people whose sole purpose in life is to design converged and hyper-converged solutions. Look at those best-in-breed components and integrating them and ensure that they will work together in a cohesive fashion. What we will then do is take that blueprint and actually manufacture that ourselves. So we will take those components and build them in the factory as a single entity. We can then manage that as a single entity and not have to worry about the individual element and managers of those component parts. We manage that converged and hyper-converged platform as a single instance. For me, the right-hand side of the slide is really where it becomes relevant to organizations because, it isn't difficult for a company to go out and buy some server storage and networking and stand them up and make them work. Where it becomes challenging is if you have a problem. Who do you phone? Do you phone the server manufacturer, the storage manufacturer, the networking manufacturer, the software layer, the hypervisor? With the Dell EMC Converged Platforms experience, we we do support that entire stack as a single entity. So our support teams, just as a talking point, are fully certified on a minimum of 2 of the elements within that stack. And then the piece that really drives value back to our customers is sustainability. In a build it environment, when there is a new HPA driver, what impact does that have on the networking? What impact does that have on the server estate? When there's a new firmware release for the storage array, you have to do regression testing and ongoing testing to make sure that that is compatible with the revisions of firmware for the HPA driver and the operating system support. We, as an organization, provide that ongoing sustainability, and those firmware updates, patches, hardware fixes are released in the context of that converged and hyper-converged platform as a single patch release. So we can actually, the customers don't have to worry about going to the individual vendors for their own firmware and driver updates. They come to us, and we provide a validated set of drivers, given the fact that we know exactly what is on the floor within that state, and we can do that in a risk-free environment. So that's our history. We're talking very much specifically around hyperconvergence, and we've taken a lot of that ethos that we had in the early days of VCE and now Dell EMC and applied that to our hyperconverged platforms, and in the form of VxRail. And what VxRail allows us to do is it's part of that family that we have within our portfolio. So if you look at the slide now on the left-hand side, we have that build section. On the right-hand side might refer to cloud, hybrid cloud, or native hybrid cloud. Engineered systems sit very much in the middle. So validated systems typically is very much like if you were to go out and buy a Lego set. You would get the component parts, the relevant bricks in which you could use to build it, and a set of instructions that allow you to do that in a supported fashion. Engineered systems, we take that plane away. We actually build that for you and maintain it based on those 5 pillars that we previously talked about. And then we have our hybrid cloud platforms, which build upon the engineered systems to give that cloud-like experience, that agility, and the cost model associated with it. But again, if we focus in on VxRail, launched probably around about just a little over 12, 14 months ago, one of the fastest, if not the fastest growing product lines within Dell EMC, and one of the very first products to come out of that newly formed Dell EMC to use 100% Dell Technologies intellectual property. So every element within that stack is owned, built, designed, supported by Dell, which is a massive tick in the box from from organizations that really want to deal with Dell EMC. So the growth rate for VxRail has been phenomenal. Just looking at the numbers on the slide there, we launched this with some very key ideas around where this was going to be. taking the EMEA headlines from here, the largest deal was, this is going back to calendar Q1, was about $1.7 million. Average deal price is $161,000. So varying shapes and sizes of customers and organizations. The vast more, certainly the majority of our platforms have been based on all-flash technology, and that really allows us to leverage things like deduplication, compression, erasure, and coding. So the economics of using all-flash-based systems that we've seen in traditional storage arrays are now absolutely applicable to that hyper-converged space. One of the things I get often asked is, what applications lend themselves to hyper-converged? And like I say, when we launched this, we had some very clear ideas where we thought hyper-converged will be applicable. So small to medium organizations that were essentially looking to put their entire infrastructure on one platform, so data center in a box. At the other end of the spectrum, the expectation was our large V-block customers, our large legacy VCE customers would deploy our VxRail platform at the remote office or the branch office. And we also looked at, the expectation was very specific use cases around VDI infrastructures. The reality, wind the clock forward 12 months, is something very different. Which applications are appropriate for HCI? Well, if the application is supporting the virtualized environment, then it's absolutely appropriate for a VxRail environment. What we do with VxRail is it's that whole procurement experience, that curated life cycle of that infrastructure. That means you as IT professionals don't have to worry about the compatibility of the infrastructure and how you build this up and scale and grow. That's done for you. You get to focus on the applications that you see on the screen that really, as I've said before, derive value back into the business. So, VxRail is very much part of our portfolio. If we just briefly look at this slide, this really talks to the portfolio that I have within my division, the Converged Platforms and Solutions division. Focusing on a hyper-converged, we've got 4 boxes. If we draw the line across the middle, left to right, above the line is an infrastructure, a set of a portfolio that's based on our VMware hypervisor platform. And below the line, we have platforms that allow us to support not only multi-hypervisor environment, but hypervisors that aren't necessarily based on VMware. If we draw a vertical line down the middle, on the left we have our appliance space, and on the right we have our rack scale space. Both are based on very, very similar technology, but the question really comes is, where do you want to scale to? VxRail and the XC, which is based on our partnership with Nutanix, are very much appliance-based. Customers expected to provide their own networking infrastructure and manage that separately. The appliance scales in a scale-out environment, as you would expect from hyper-converged type technologies. But if you move to the right-hand side of the scale, when we start talking about hundreds, if not thousands of nodes, then that the IP network that's used to allow the nodes to communicate with each other can get quite complex to manage. So what we've done on our rack scale portfolio, both from an SDDC perspective, which is based on VMware, and a Flex perspective, which is based on our Scale.io software-defined storage offering, we integrate the network with that. So when we talk about engineered, managed, sustained, supported, manufactured, that network is included within all of that. So the management layer supports the network infrastructure, those support and break fix support the networking, but it's really down to scale. If you're looking anywhere between, well, now starts at 3 nodes going up to maybe 30, 40, 50 nodes, then probably an appliance play is probably more appropriate. But if you're starting at 10, 12, 15, 20 nodes and scaling into the hundreds, if not thousands, then the real consideration is to look at our rack scale VxRack platforms, either SDDC, which is purely based on VMware, or Flex, which just gives us that choice of hypervisor. Again, focusing in on VxRail, people often ask me, so in the appliance space, you've got VxRail and you've got the Dell HCI platform. There are lots of differences, and I think for me, it really comes down to how this is built. As I briefly mentioned, VxRail is supported and built to work with VMware platforms, and actually more importantly, it's built in conjunction with VMware. So we've got the hardware elements of Dell EMC, the software elements of VMware, and then that curated experience of my division to bring together that packaged solution, which is really built around VMware vSAN. So if you are a VMware customer and you are familiar with vSphere and maybe even vSAN, then why would you look at anything else? why would you introduce an additional management plane into your environment to manage that software-defined storage layer when it can come all pre-engineered within that VMware stack? We draw some comparisons between perhaps two different ways of delivering that software-defined storage layer. We could take, on the left-hand side, would be our XC platform, and in the rack scale, it would be our VxRack Flex platform. There's very much a separate storage VM to deliver that software-defined storage. If you look at, on the right-hand side, which is based on VxRail and VMware SDDC and that rack scale space, then that software-defined storage is integrated within the kernel. Now, there are various people within our business that would sit around the table and have a conversation for hours on end, arguing the benefits and the merits of doing it one way versus the other. This slide is not there to have that discussion about one way or the other. This is about identifying the differences, and in a VMware environment, it makes sense to have that integrated into the kernel. When you look at using Hyper-V or KVM and perhaps even VMware on a single platform, then we go down the storage VM approach, either using Nutanix or the Scale.io software. So if we just let this slide build out, to a certain extent, VxRail is a packaging exercise for vSAN. There are a number of different ways of procuring vSAN. You could go and buy your own server, buy a vSAN license and integrate it yourself, and think back to the early slides that I had in my deck talking around that build it mentality. There is a halfway house between that and a full buy experience, which is VxRail, which is vSAN ready nodes, which there is an element of coming pre-engineered, pre-configured, but there's a lot of manual configuration that goes with it. At the far end of the spectrum, we have VxRail, which not only packages and automates a huge amount of that implementation process, but we also added in additional functions and features to really benefit and add benefit to that vSAN experience. So we have data efficiency services. We have data protection pre-built, pre-installed, ready to go. There's an ability to put QoS on certain VMs, and we also have the ability and pre-licensed and pre-installs to migrate certain workloads out into a certified cloud platform out the box. So if you're really looking just to open the box, cable it in, turn it on and spin up some VMs, then VxRail is definitely the right packaging exercise for that vSAN environment. So just expanding out what's included. So on the left-hand side, we have a number of features and functions and licenses from the VMware stable. We have on the right-hand side some additional, they're third-party outside of VMware, but they're very much products as part of the Dell EMC portfolio for data mobility, for replication, for moving data into the cloud. And then we have that piece in the middle, which is the glue that holds us all together, which is VxRail Manager. VxRail Manager is the piece that does the automation around the implementation. VxRail Manager, in conjunction with the secure remote support, is the one that will dial home either to yourselves or to us to say, there is a problem, there has been a problem, or there could be a problem, so that predictive maintenance. So again, going back to that packaging conversation, VxRail really gives you everything you would need to deploy a virtualized environment in your data center. Now, there are a couple of flavors that you can look at. So we don't include vSphere licensing with this. There is an expectation that customers either have a larger ELA with VMware that can leverage those licenses, or will go and procure additional licenses with the purchase. You can either bring Enterprise Plus or vSphere Standard. And for me, the real difference there is the level of automation you get as you go up the scale, as you go up the food chain, as you increase the number of VMs. So if you're in a 4-node system and you need to evacuate a node to put into maintenance mode, it isn't a huge manual ask to actually manually move those virtual machines onto different nodes. If you've got 20, 30, 40, 50 VMs, then maybe there's an element of automation you want. And if that is the level of automation you want, then Enterprise Plus is the appropriate license to bring to the party. And for me, there really are the two differences between the two. So, one of the very few product slides I use this in the session. VxRail is a hyper-converged platform, and by that I mean everything you need from a hardware perspective is in the box. We have CPU, we have memory, we have power and cooling capabilities. There are networking options between 1 gig and 10 gig, and actually we can go to multiple 10 gig links. For very specific use cases around VDI, we have the ability to put graphics accelerator cards in there. And then we also have all-flash or hybrid dispatch based on the use case and the cost analysis and what kind of capacity you're looking to get from that system. So again, going back, we'll meet VxRail 4.0, right? So what does this bring? It's a relatively recent release. We introduced as part of 4.0, as I mentioned before, the platform on Dell-based Power Edge servers, which is a fantastic piece. We changed the rules. We started a 3-node entry point. We introduced one-click software updates. But more importantly, the stuff that you don't see is some of, again, that automation that we've integrated to make this build experience versus buy VxRail, the automation that you typically have to do in that build world is phenomenal. And we have had customers that have unwrapped a node, albeit into an existing cluster, and within 15 minutes of being plugged in and powered on, they're actually migrating workloads onto that system. That's no mean feat. That allows you as an IT department to be incredibly agile and not waste time building infrastructures, maintaining infrastructures, working out compatibilities of software, hardware, and firmware revisions. You can focus on the stuff that really brings value to your organization. So every vendor presentation wouldn't be complete without a family phone. So this is probably the slide I hate the most within our business, but I leave it in here just to really draw a point to that. So when I'm talking to the architects who work for me across EMEA, we don't focus on the product names across the top. We don't focus on how our marketing teams have positioned these. We focus on the customer use case. We do some analysis on your current environment, whether it's physical or already virtualized, to understand the performance metrics, the capacity requirements, the compute cycles, the number of vCPUs, the amount of networking bandwidth. Once we've got those requirements, we'll put that into our configuration tools. And coming out the end of that will be a couple of options based on your requirements, the customer's specific use case for now and in the future, because we have to think about scaling into the future. And based on that, we'll make recommendations whether we go for G, E, V, P, or S nodes. The only real exception, the only differences is some of them are 1U and some are 2U. Some have the ability to have additional memory spots. As you go further up the performance curve for the V and the P, there are some faster processors with greater number of cores. But the only real difference for me is the V allows us to have that graphics acceleration card, which is really where we use in that high workload VDI environment. So that's the family portfolio, and I think we've come on to the final slide. So at that point, Mark, you're back on the line. We'll take any questions that may have appeared in the chat or the Q&A, and is anyone in the line? Thank you for listening.
Great presentation, Mark and Mike. We do have a question here. This one's probably for Mark. So, Cajun 989 just wants some clarification here. Why do you consider hyperconvergence to be more predictable cost-wise as opposed to the cloud model? Why isn't the cloud model predictable?
Oh, yeah. Okay. So I'm certainly not trying to hate on cloud or anything there by that statement. I think that the options available provide a certain degree of choice. So I think that what we tend to see a lot of the time in the cloud is kind of more of a tariff-driven pay-as-you-go model. Each kind of workload or each discrete portion of resource that you might be spinning up is a phone off the hook in its own right, costing money, which is going to come through in the form of a certain degree of billing that's going to be coming through there. Now, that isn't to say that you can't control that to an extent that you might have a certain amount of predictability, as long as you have those levels of control, and that you can kind of fend off those people who might want to just start throwing workloads onto that resource willy-nilly once it's there, because obviously once it's there, it's quite easy to consume, as we've seen in the past with the early days of virtualization, where we could have virtualization sprawl. Once you've got those resources, it's very easy to just start consuming them at will, and of course it's even easier to do that in the cloud. But as long as you can have good control over that, as long as you've got good gatekeepers who are sort of saying, right, no, any kind of workload you want to spin up on there, we're going to have to check that and make sure that you're not just doing that kind of without any evaluation of the cost, then you can keep a certain degree of control over that cloud experience. So certainly it's not beyond the realms of possibility to have a fairly well-controlled experience there, but you've just got to be very, very proactive in terms of managing that experience and making sure that the billing isn't going to sort of spiral out of control there. I think that the area where Hyperconverged is different, that it's going to provide a different approach for how the costs are going to be controlled, is that you're still procuring on-premise IT, but because of the fact that you are procuring that in potentially a slightly different way than more of a traditional stack, it does allow you to start to sort of apportion the stage at which you acquire resources over time rather than in one go. So if you would to typically, for example, say, okay, we're going to procure some new IT resource for the business by building an IT stack and going down that build route, and we're going to provision that and say that we want that for the next 3, 4, 5 years, and it needs to have the resources to accommodate the growth in whatever workloads we're going to be throwing at it for a specific project or a specific business unit or even the whole business, depending on the size of your organization, for that time span. So you've got a lot of design work up front, and then you've got a big CapEx spend in one big bang to acquire that. Whereas with the hyper-converged route, you have a little bit more freedom and flexibility to say, okay, well, we don't really know what our resource requirements are going to be in 12 months' time, in 2 years' time, 3 years, etc. But we can acquire the resource pools that we need for now, put those building blocks in place, and then as you get to those stages where you need to grow and you need to expand the platform, then you can bring those additional building blocks in and build up your environment brick by brick with the resources that you need. And that does allow you to spread the cost over time. You are sort of pushing those additional spends out to future budgeting years. And as long as everybody's on board with that approach of saying, right, we're going to spend some money now, knowing that we're going to be budgeting for the expansion of this platform a year down the line, 18 months, 2 years, whatever points you're happening to reach those stages. So, you know, I think this is one of the reasons why, of course, Hyperconverged was sometimes thought of as being a good fit for Hyperconverged, for VDI and for web hosting, those kind of environments, because, you know, you've got that ability to say, okay, well, as and when we get more people accessing our platform, we can make an assessment, look at the resources that we need, and expand. And it doesn't have to come without a degree of predictability. You can sort of say, okay, well, we know roughly how much this is going to cost to expand when we get to those points, and we can add those additional resources in. So that's not meant to sort of suggest that you can't gain predictability of cost in the cloud. You absolutely can if you've done a lot of planning in there and you are sort of being a good, strong custodian of the resources that you've got there and the workloads that are being thrown on. It's just obviously a different approach. And I think it does offer for those people who want to continue to maintain on-premise resource a good level of control around that.
Wonderful. Thank you so much for digging a little deeper on that. This question is for the both of you. What would you say is the most important key takeaway from the presentation as a whole? What would you like people to really remember after this presentation?
I guess I can go first on that one. So I think the main thing is that I would say is that the highlighting of the choice that we now have in how we can procure and acquire the IT resources that we want to get hold of for our environment. So we do now have a huge amount of flexibility to be able to deliver and deploy the IT resource that we need, and that really should speak to that position of thinking about, you know, think about the traditional approach that you have to go through to get hold of IT resources in a traditional IT stack and the level of procurement and budget fighting that you might have to do. If this can deliver a faster, speedier way of getting hold of those IT resources, then I think that that's going to be good for all of us to be able to get hold of these things in a more timely manner, being able to adapt, being able to satisfy the requests that come our way for IT resources, sometimes at short notice and often an unreasonable manner. We all know how this can sometimes be. So being able to shorten the procurement cycles, hopefully speed up some of the design cycles in this, can be of big benefit.
Brilliant. And there's the perils of going second on a question you've got a similar answer to. So in the spirit of not repeating what Mark just said and talking around choice, I think for me the important piece is hyperconverged is not binary. It's not all or nothing. We have customers who have embraced hyperconverged wholeheartedly and moving all their workloads onto a hyperconverged platform. We have other customers that are using this in conjunction with other technologies. So there are certain workloads that lend themselves very well to a public or a private cloud environment, but certain workloads like VDI, specific projects where budget is ring-fenced, that hyperconverged is the right answer. One of the things that's come up in the chat window is questioning around the scale and the fact that typically in a hyperconverged environment, then you can't scale compute independently of storage and vice versa. That's not strictly true. So as long as the nodes are of a similar disk type, so either all flash or otherwise, we have different nodes. Some are more storage focused, some are more performance focused. So if your use case is actually I need more storage relation to the compute requirement, then you'll perhaps look at the S nodes, so the storage-centric nodes. But if it's a performant environment, then perhaps the P series would be more appropriate to your environment. And of course, from a capacity perspective, you don't have to fill those drive trays up on day one. You can add an increased capacity based on individual drives. And then we have, again, to sweat that asset that much further, things like dedupe, compression, erasure, encoding, so you can effectively do what is known as more with less. So it is that choice, but don't feel you have to do everything in one hit. Of course you can, and we have got a great number of customers that are doing that, but think of this perhaps for specific projects or for specific workloads or even specific use cases, particularly if you're coming from a very traditional build it environment. This might look for somebody that's a toe in the water to actually start that journey. But yeah, it gives you that flexibility and choice.
Wonderful. Thank you both for such a great presentation and for answering those questions for us. Looks like that's all we have for today as far as questions go. So I do want to remind everyone that if you had to step out or if you missed any part of today's presentation, you will be receiving an email in a few days with the link to view the webinar on demand. Special thanks to Probrand for creating this content and sponsoring the event. Also, huge thanks to each and every one of you for tuning in today. We hope to see you back soon for another Spiceworks Partner webinar, but until then, stay safe and keep it spicy.